we have 35 participants logged in. Should give it another minute, Julio.
Sure. I was muted. Go ahead.
I know. I hope everyone had a good break. So I want to have an informal survey. If we were to have this meeting in person next year, would you be in favor in Miami? Basti, do you want to send out a participant survey? Should we just ask people to chime in the chat?
I see a couple people have a thumbs up, so I can
do
survey, but that's a good note.
I think it would be really lovely to all get together again.
Yes, I agree.
Thank you, Renata. Wonderful. And Miami would probably be the easiest place to get started.
I completely agree. It would be great to see you all in person. I will say that as we emerge from the pandemic, Vera Rubin and Noir Lab are committed to traveling less and reducing our footprint. So I would hope that any meetings that we can set up that are face-to-face would also have hybrid options. I'm not saying we would not send anybody, but sending everybody is probably not the way we're going to roll into the future. And this is a message I'm giving everybody, not just this group, of course, that Vera.
Yeah.
To.
I think for the most part, hybrid options are here to stay. But it would be nice to get together. Okay. Well, now we're still at 35. Let us not keep Luis in suspense. We have a presentation from Red Clara, Luis Cadenas. I know you're probably around here.
I don't see him right now.
Oh, well then we better wait. Paula, you're muted. Did you want to say something?
So sorry. No.
No. Okay. Well, let me ask you this. Aloisio, are you ready?
I don't see him here either.
Apparently our refreshment break is too short.
Let's see, Marco here. Who's after Aloisio?
That's Mark Foster and then me. We're both here.
I don't see Mark.
I do.
Joshua, I'm reading your comment and I completely understand. I hope by 12 months from now, we'll be able to do something in person, but
amen.
We don't know.
I'm definitely here, Julio.
Oh, there you are, Mark. I don't see you on the list for some reason. It's weird. Okay, Mark, can you start now? Because we're missing Luis Cadenas and we're missing Aloisio at this moment.
Can you folks see this?
Yes.
Great. So this is a pretty minor update from what I presented last year. It's got significant input from Richard Dubois, whom we're standing by. We're going to hear from him shortly, and I've stolen several of his slides, and so I won't really talk too much about them. I'll let him talk about them. So the infrastructure piece of the U.S. data facility, part of what you're going to see here or the focus here is mostly on the networking element. And then I've got a couple of pictures of building under construction. But what motivates and drives some of the networking element at the U.S. data facility are these this slide and the next slide, which is about the data processing. And so, we concerned about the data rates and the amount of data in and out, both for the prompt processing and then also for the DRP. And so to that extent, we've got these two sort of notional diagrams that show directions and movement of data amongst places. And this one's kind of the more interesting one from the standpoint of where all the data needs to explode for the data releases. And so, I think from that standpoint, as I said, I stole these from Richard. He'll talk about these a little bit in the next session. So hang tight with us. The other piece here is for the USDF, the US Data Facility for the Rubin Observatory. It's going into it, or it's combined with this facility that we're calling the SLAC Shared Data Facility. And we're looking at, from a standpoint of not just networking, but physical space of both storage and computational resources. And as you can see here, there are a number of different projects that have significant input, significant support from the shared data facility. But what the sort of those takeaway bullets there are that the computational resources are going to be dominated by this LCLS2 project that's getting ready to come online. We're still a few months away from so-called first light there. But it will be coming online in the coming year to start doing some data processing. And then the storage is dominated by the Vera Rubin US data facility in terms of the total data store. Here's another stolen slide. I'll say I got it from Richard, but I suspect that we had input from others, Richard. But this is something where we kind of need to look out, past our first few years and say, where are we going to go in terms of the data rates? And I think one of the key pieces here is that upper line, the maximum data rate out of SLAC, and where our trajectory needs to be on the networking support for that. And we can see, we're going to exceed, at least at this point, sort of several years down the road, we're going to exceed 100 gigabits. I'm anticipating that some of that may happen faster, not necessarily just for Vera Rubin, but for other activities as well. And so to that extent, in the Vera Rubin piece, in the parts that we're stitching together amongst, and thank you very much, Geronimo, for that great presentation on AmLite, and for the others in the Reuna and other parts of that. It's important for us to sort of see this combination. But once we get to the continental US, and AmLite then needs to carry this these two circuits, how do we do that to get to SLAC? And that's been some back and forth discussions amongst ESNet, AmLite, and ourselves at SLAC. And what we have here is the sort of the current intended diagram of how to get the first 200 or two 100 gig links up and plumbed into SLAC. And what I want to show you, and for some of you, I apologize, I wanted to get this slide in front of you earlier. And so this is, a broader audience that's going to see this right now than some of you had said, hey, we haven't seen that before. So I apologize, it's that you haven't, that this is the first time that you've probably seen this, at least publicly. But what we're talking about is bringing two optical circuits into Atlanta and then handing those off to ESNet and having that carried over a managed backbone that is the ESNet managed backbone between Atlanta and Menlo Park, SLAC in Menlo Park, California. And we will plumb that with pairs of 100 gig links in the backbone. The ESNet 6 backbone just been upgraded. It's gone full motion in many different directions to be able to carry this traffic. part of this is also to provide a backup link, a resiliency link through Chattanooga. And so as we see here, we've got one piece that comes primarily through Atlanta. And I'll try not to steal too much of the ESNet thunder. We're going to see some of that in the net meetings, but for this meeting for today, I don't recall, was Paul on the agenda? I should know that off the top of my head, but there'll be two pathways to give us some resiliency through Atlanta instead of it being just a single point of failure there. Key pieces that are takeaways here is that we would use this virtual private routed network, VPRN. ESNet's been doing this for the LHC community for several years, very successfully, providing assured bandwidth, providing good resilience, providing good connectivity. And so this is something where we'll leverage that experience and be able to kind of use very similar parts and pieces for the management and monitoring. It's a couple of BGP sessions between AmLite and ESNet, a couple of BGP sessions between Slack and ESNet to carry this sort of dedicated network. A salient point to that is that there's an opportunity, and this is my final bullet here, that this VPRN could be extended to other locations. So if there's a need or a desire to grow out sort of this dedicated resilient transport to other locations besides the ones that we've got noted here, then it's a fairly straightforward addition via the ESNet backbone to other locations, assuming that the underlying pieces can carry the traffic that's needed. The other piece there, the next to the bottom bullet, is that we believe we can do an early implementation of this and do some pretty good ringing out and testing. This has been on our agenda for the last, I'd say, month or 2 months to put some pieces in place so that we could do some early testing and gain some assurance for the overall program, for the Vera Rubin Observatory program, so that the long-haul network we could test out and make sure that this particular solution is viable. If we determine there are issues, it gives us an opportunity to do some tuning or perhaps revisit other approaches to what we've described here. For the US data facility itself, and I mark this notional just because it's kind of a cartoon, and it's very similar to the cartoon that I showed last year. And that is to say, we'll have quite a large number of servers with top-of-rack switches, and those top-of-rack switches will be 10 gig and 100 gig capable, and there will be 100 gig uplinks to a routed infrastructure, multiple 100 gig uplinks to a routed infrastructure that would be carried through the Slack core routing infrastructure to the Slack border routing infrastructure, and then multiple links to the ESNet infrastructure. Part of what I show here is N by 100. Right now we have 2 100 gig links to ESNet, and ESNet now has, with the ESNet 6 upgrade, that is essentially all but complete. We've got the ESNet 6 has a few other places to do a little bit of work, but there's a dual optical infrastructure, 2 different ways to get waves in, and with this latest one using the Sienna wave servers, they now have the ability to hand off 400 gig to clients instead of just hundreds, and we'll grow into that. But right now we can grow our 2 100s to say 4 100s, and that is our current initial stage plan, is to add to the 2 100 links that we've got here, add 2 more 100 links that would be the place that we would do this Vera Rubin peering over. And so the additional 100 gig links would give us the ability to have that additional capacity, with the expectation that in the coming year, we'll be able to upgrade these links to 400. Slack is getting some new border routers, and we're undertaking sort of a multi-year effort to upgrade not just our border, but our core infrastructure to be able to carry 400 through our infrastructure. And our current target for this border upgrade to 400 is in the calendar year 2023 timeframe. Okay, the other piece of the US data facility, part of it is there's some existing facility called SRCF, that stands for Stanford Research Computing Facility. And it's a building that exists, and we've had a large number of racks, and we'll do some pre-ops staging there. US data facility already has some equipment there that would be sort of the pre-ops staging. And then you can see, and it's a hot aisle, cold aisle. It's like many other data centers that you've seen. So this picture off to the right here is just a part of that, where we've got areas that isolate the cold aisle and hot aisle. It's a fairly large building that's going to essentially double in size. And so this is the piece that's kind of to the east. This is the piece that's to the west. And you can see we've got most of the first floor under completed, or the walls are completed, and then the second floor is going up as we speak. They're working on it every day, and that's what will house the core pieces of the Slack shared data facility, including the USDF. So I kind of flew through that. Do we have any questions? Great.
Okay, well, thank you for the presentation, and maybe there'll be more after Richard and Paul.
I would say for Richard, Paul may have some useful things to add to that, but I would say the real meat of the US data facility is what Richard is going to present. We've got a question from Joshua. Sorry, Joshua.
I was trying to find the unmute button. So those bandwidth projections are actually really scary. The thing that leaps out at me is thinking about catch up if there is a fault or a lag. I mean, obviously the data products aren't going to be available on a continuous basis. So in terms of modeling this, it seems like after a DR happens, all the data is going to want to go all at once. How bad is that going to choke things? And or if there's a glitch or a transfer stop, what do the catch-ups look like?
Yeah, and so I would say that's probably a question more for Richard or for some of the data management team. From a network, I'll try to answer that from a networking part. Part of what you see here is a trend line, and the first couple of years we'll gain some experience with that. It's the engineering from a networking standpoint, and some of what we saw earlier. There's a whole lot of resiliency and a whole lot of monitoring being put in place. And so to that extent, our hope is that we can project and identify if and when faults occur ahead of time, so that the actual data movement doesn't experience faults in the network itself. But to the extent that it can, then the question would be, where are data capacitors? What do our data capacitors look like? And that's kind of outside my realm to really answer that in terms of what they could handle from a temporary storage and then a surge. Do we have enough headroom on the networking to handle a burst that's above what we're setting as our baseline? And so as we look at a trend line here, it's partly why I jumped right into saying, we can go to 100s, but our plan is to go to 400 and then above that in fairly short order. So 2 400s in fairly short order. That's the connection between Slack and ESNet. ESNet's got this great infrastructure in terms of the growth ability and the expandability. Now, what does that mean for other handoffs in other locations that are going to be sinks for this data, or sources for the data that may be disrupted? That's a complicated question, and I don't have a real straight answer for you, Joshua.
Yeah. No, like I said, it's just kind of scary to think about this, especially, I mean, we all know that we're not going to be able to perfectly balance this traffic out of here. So there will be bottlenecks, and that bottleneck is going to set a limit saying at a certain point of transfers having stopped, we literally can't catch up in a year.
Yes, that's absolutely true. And that's where at least some of our, I'd say our performance testing and our monitoring, our ongoing monitoring and sort of the dashboards we'll put together to help us see those trends in advance of when they happen. I think it's actually going to be key for our data management teams to kind of keep an eye on that and sort of be able to look out, a couple, 3, 4 years down the road.
Yeah. I mean, what I would suggest is thinking about like writing down, this is what the critical point is. Like if we have so much outage or our transfer rates are lower than we think we are, we're literally not going to be able to keep up or recover from an outage. Say it's out for a week, well, then it's going to cause these knock-on effects, and just kind of think about that as an input to capacity planning down the road.
Good suggestion, thanks.
Okay, so I think we can get more into this a little later in the program, but at this point, I'd like to introduce Luis Cadenas, who's going to present on Red Clara, followed by Aloisio for RNP. So, Luis, I know you're here. Oh dear, did he disappear again? Aloisio, you're there, right?
Hi, Heidi. Yes, I'm
Hi.
here.
Would you mind giving us your presentation, because we seem to have misplaced Luis?
No problem. I can do it.
Thank you so much.
Just a minute to start the
Of course.
the screen sharing. Are you seeing my presentation?
Yes. Yes.
Okay. Good afternoon to everyone. I'm Aloisio from RNP. I'm a engineering coordinator for the backbone team. And I will talk a little bit about the RNP updates. If the PowerPoint help me. Okay. Well, this is a picture of our current backbone. It's the 7th generation of our network. It is still in deployment. It will probably continue in deployment for the maybe next 2 years. We have a lot of challenge to overcome, but it's a backbone that will be deployment in partnership with many companies that own dark fiber, most of them OPGW fibers. There are the electric power companies. Some are public, other are private. Chessi, Eletrosul, Furnas, Taesa, Madeira, and Argo. RNP established 20-year alliance with them. So it's a very long term. So it will be very cool for us. We also have a partnership with the Telebrás. It's like a private and mixed private and public telecom company for a 1400 gig circuits. And more recently, we are establishing swap with private ISPs. So our strategy, we'll have no leased line circuits or RU payments for interstate dark fibers.
I'm not getting any more audio. Is it?
Oh, sorry.
I heard you say dark fibers, and that was it.
Okay. I was talking that our strategy, we are not expecting to pay for leased lines or interstate dark fibers. The only exception will be the redundancy for the Boa Vista in very north of the country, because there is no redundant paths through Brazil. It should be done using Venezuela and a submarine cable from GlobeNet. So we will still be paid for that for some time. Most investments of RNP is in electrical infrastructure, optical equipment, in some cases, hardware and software support. These are part of our agreements with these partners above. The green linings are the 100 gig deployment, and the blue line in Fortaleza, São Paulo as well is a submarine cable from Light project. In terms of international connections, we have agreements with Light and Bella, in case Rede Clara plus Gian. In points of connections in Fortaleza, that we have a global exchange point. In São Paulo, and in partnership with Rednesp and the former ANSP. And in Porto Alegre, more recently, because of Rede Clara deployed a point of presence in RNP POP. So RNP also has dark fibers in Fortaleza and this is São Paulo. In Fortaleza and São Paulo, connecting the most important sites. Fortaleza, the T-Spark Land Station that we Amlight has 100 gig ring. The Telxus, the point of connection of Ela Link, the Bella Submarine, and the Angola Cables, the point of connection of Monet and Sachs to Africa. And São Paulo, RNP established dark fiber ring connecting the most important Equinix sites to the RNP POPs. For this year, we are working on activations of the 13 new 100 gig circuits. Some of partnership Celebrais in blue, and the others is a mix of the electric companies. And I put here the Curitiba, São Paulo, because we don't have a 100 gig connection between the south region to southeast region yet. So we hope we could have it by the next 30 days. And this number of 13 will probably be increased by at least 5 because we have closed some agreements in the swap process we run it. RNP also start new phases of the project with Eletrosul in the south region in purple, in Furnas in the southeast, in the center west. We expect to receive the budget to start this project in the third quarter of this year. It will be a very important budget for us because of these strategic key points from Curitiba to Londrina and Porto Alegre, and also in the southeast of Brazil, in direction to the chefs network here in Northwest. Other more recently strategy we are running is the swap channels. We are at this moment closing the process with the last negotiation. We already closed the negotiation for 13 routes with 3 internet service providers, and we also expect to close the more 7 routes, including some on the south of Brazil. And I put here some of these routes in black, so we can see how they will improve our connection between Fortaleza to São Paulo and then to Porto Alegre. There are other routes, but I would like to show this. They're more related to the international partnership. And the conclusion, RNP continuing to seek new long-term partners to develop its new network. We are running some conversations with partners. Maybe we have more routes, not routers, in future. We still prefer scalable solutions in terms of like a half of the spectrum or a quarter of the spectrum, but the swap strategy will become a key point to the success. And of course, the scalable solution are needed so we can do the swap. And I would like to comment that RNP is making all the efforts to honor the commitments made with the academic partners, LSST and MLight, and also with Rede Clara Bella. We are working very hard to overcome the issues and to deliver everything we committed to do. Thank you.
Thank you, Aloisio. Do we have any questions at this time? Okay, well,
I'm sorry, there is one question. Are there any plans to improve connection between Rio and Petropolis to access the supercomputer?
From Rio to what point?
Petropolis.
Petropolis?
Yes, I'm sorry.
No problem. I'm sorry. I just see my video was closed. Yes, there is. We have a plan to not a plan, but to have a project to establish a 100 gig connection to Petropolis.
Perfect. Okay. Thank you.
okay. Luis Cadenas. We're in deep anticipation to hear your talk. And I have to mute because my dog is barking.
Yeah, apologies, but I had issues with my computer. So now, thank you very much for this kind invitation as ever, Julio and other SAC partners. I'm going to share my screen and try to give you an update as complete as possible about Reclara and the current situation of the network and the projects we are working on. So beginning with the mission and vision of Reclara, because we began a planning process recently. We are conducting this planning process since October or November past year. To update our mission and vision and to make the planning for the next 4 years of work. And just to mention that we made this change to make more clear the focus of Reclara in supporting the national research and education networks in Latin America to, through them, impact in science education and technology innovation all over the region. So this is a new mission and the new vision. We are still finishing the process. We're expecting to finish the planification process on May. We are going to have an assembly in Montevideo, and we will close all this process and have a new and refreshed plan for the next years. It is necessary because it was not done after 5 years. We have almost 5 years with the same plan. Here, I would like to begin with the news that is already old. You know about Vela submarine cable being inaugurated the last year in June. You can see here some of the pictures about the deployment of the connections and the people arriving to Praia Futuro, I think, in Fortaleza. And well, it has been a quite big success if we take in account that in the recent time we have grown the amount of bandwidth and traffic that is going through the Vela subsea cable. As you maybe remember, we had a connection with Europe through the United States of something around 10 gigabit per second. Now we are achieving up to 20 to 30 gigabit per second of traffic, and we are expecting this to grow quickly as we connect the countries in Latin America through the Vela T project. And in general, with this project, we have changed in a very relevant way the sustainability of Red Clara and its members. This picture is showing you the links that we are almost ready to inaugurate in the north. You can see in dark blue the south part of the Vela T connection coming from Chile to Argentina and to Brazil in Porto Alegre, and then through the internal RNP network to Fortaleza. And also the connection in the north that is going from Ecuador to Colombia, Ecuador to Panama. And this is a mistake in this picture because the link should be Ecuador to Panama and Panama to Brazil. Those links, in this case, in the north, we're talking about up to 300 gigs of capacity, and we are beginning with 100 gig that will be inaugurated next week, at least in the case of Ecuador. And in the case of Panama, and as a general close of the first phase of the Vela project, we're planning to have an event probably on June when we finish this phase of the project. So with this, as you can see, we have acquired a big capacity for the next 15 years. And this is changing in a very important way the sustainability of our initiative. I would like to thank also to the SAC partners and Julio and all the people that is here in the meeting. Because of the collaboration we have maintained over the years, it is quite relevant for us. Not just to say that is important because of the growth of the research community, but also because we can provide each other support and benefit with this collaboration. So I want to make this gratitude expression public here in the meeting. We made recently the BELA agreement, which is providing us mutual backup for the multiple connections we have in intercontinental connectivity between Africa, America, and Europe. It has been recently signed and announced in our social media. In this picture, you can see just the Vela infrastructure. Here, the graphic or the picture is right. So the connection is going from Ecuador to Panama, and Panama to Brazil. Right now, this connection is working, is functioning. We are still expecting the arrival of the routers we purchased for this part of the project. In Panama, I think they are already in Panama, but it's something related to, you know, the internalization of the equipment in Panama and all the tramites with the government to get the equipment free to go to the place we are going to have the connection. And we are going to make a major change in our routing layer that will connect not just Vela, but also the other services that we have in Panama. So it is going to happen probably in the framework of 1 month, more or less. For the future, we are working now in designing and submitting a Vela 2 project, phase 2 of the Vela project, which is going to be focused in improving connectivity in Central America and trying to get connected Dominican Republic as a first objective. We expect that this project is going to span 4 years. And the expectative that we have is to support the development of the research communities in Central America that, as you maybe can imagine, are very weak. So we are planning a different strategy that we followed with the phase 1 of VELA, which was with countries that has more resources. In this case, Central America is weaker. And we are looking to integrate Dominican Republic because there is a project to create a cyber security center in Dominican Republic with the support of the European Commission. So they have asked us to consider the connection of Dominican Republic to the rest of the VELA infrastructure. This is a first step of something that we already designed. It's a VELA 2030 view or proposal that is looking to grow very much the connectivity in Latin America, including the Caribbean, to integrate all those countries to the connectivity to Europe, and also support better the functioning of the national research and education networks in the countries that today are not connected. We are using also a kind of service that we are going to use in order to provide services to countries where we have not direct connection. In particular, for example, we are going to launch soon an event welcoming AT to our community. And they are going to get several services, including EduRoam, EduGame, and others that are not depending on the physical connectivity. But the long-term goal is to get them all connected to the infrastructure. So in the 2030, we are looking to have the 16 additional Latin American countries, Latin American and Caribbean countries, and to get them connected to Europe, North America, and Africa. I would like to mention, now finishing with the few last slides to reinforce the message that Reuna sent about the relevance of the Humboldt cable and the potential opportunity to have an Antarctic cable. We have been working very closely with our partner in Chile, Reuna, who has been supporting both initiatives since the beginning. I remember that in one of the meetings a few years ago, Paola Arellano already mentioned the Antarctic possibility, and we now are closely to do something, because as you already listened to the presentation of Reuna, there is a possibility to begin soon a feasibility study of the connection of Chile to Antarctica, which is going to be funded by the regional government of Magallanes, and also with the interest of the Desarrollo País, which is a national organization in Chile which is looking for this goal. It's something very relevant, as you may, as you know, of course, because many of the applications, but in particular because of the services to monitor the Earth, like Copernicus. Copernicus is having an impact in terms of the data about climate change, and having a connectivity in Antarctic will help us to have a greater frequency of update of the data that is collected by the satellites. So having connection in Antarctica is something that could impact all the Earth monitoring programs, because of the frequency of updating the databases and the data centers with the data collected by the satellites. And in the case of the Humboldt cable, of course, the connectivity with Asia, I think, will be relevant for the astronomers and for the community that is represented here. And the ambition that we have as a regional network is to be able to do something similar to Vela, acquiring a long-term capacity, a long-term and big capacity in this Humboldt cable to provide this additional connectivity to the Latin American community, no? And will help us to have an additional route, an additional backup route for many of the connectivities that we already have. And this one is a picture I took from a presentation of Reguna, where they talk about this opportunity of the Antarctic connection. As you can see, of course, is the closest path between any continent and Antarctica. Of course, not necessarily we are arriving at the right side or the more interesting side for the major part of people, but is quite close. So we will still have to do many work to be able to get this connection in the future. But as I mentioned, we have this ambition of having the first connection to Antarctica coming from South America and providing this access to the community of researchers all over the world. And I think it was my last slide. Thank you for the opportunity, Julio, Heidi, etc.
Thank you. Thank you. Do we have any questions? Okay. So now,
let me make a comment. Let's just make a comment. Thank you, Luis. I appreciate all of the kind words and the collaboration. It's been great to work closely with your team and especially with the links, the new links that you're adding to the AmLite footprint that we're sharing together. That's of great value to us. The link to Panama has been a good addition.
Yes. Thank you, Julio.
Thank you.
Okay. So Richard Dubois is going to present on the USDF data movement and multi-site processing.
Okay, and actually just let me move the video back where I can see it. Or not. Okay, so hopefully you were listening when Bob was telling you all about Ruben yesterday, so I won't be giving you much of that. Oops. Okay. Okay, so here's the overview picture, sort of nutshell of Ruben. So so we're taking something 20 terabytes a night. There'll be sequential 30-second images. Lots of alerts coming out of the prompt data, so 10 million alerts a night. We need to get the data from the basically shutter to Slack within 6 or 7 seconds. And then we have 1 minute to turn around prompt processing to do the alert stream. We'll also be doing daily the prompt processing. And then every year, we'll gather up all the data taken to that point and reprocess it. So essentially, so it's a fixed period of time. We've set 200 days to do that. And by the end, we'll have some 5 million images. These are 3 gigapixel snaps. And the catalog with some 37 billion objects will be 15 petabytes. So good sized database. The alerts will go out to community brokers. And we'll have a number of data access centers to deal with. They're independent ones, and then there are the major ones, which are the main data facilities. So I'm going to run to that. And then down at the bottom here, we have the Ruben Science Platform, which is basically our idea of bringing the science users to the data. So This is portal-based. We have notebooks, tap protocols for talking to databases and the like. Okay, so just a little organizational thing, but basically, there's 3 major data facilities. Slack is the USDF. We'll do 25% of the annual release processing. It'll do the prompt processing and provide some amount of compute to our users. The French data facility at CCIWP3 in Lyon will do 50% of the processing, and the UK, which hasn't quite set their sights yet, will do 25%. We have lined up, I think, about 15 independent data access centers, and we expect them to serve various fractions of the data, from a light database up to a significant fraction of the data. And then we anticipate clouds. So I'll say more about that. So here's our model today. So we have for the US side, we have this hybrid model. So on premises, we're doing all the big processing, the storage, and we'll put the fancy astronomical database server, QSER. And then we plan to put all the users, the science users, into the cloud. We have been prototyping an interim data facility in the Google Cloud. So that's kind of where the pictures come from here. And so they will have the science platform set up there. We'll put some of the data into the cloud. We're expecting to put co-eds, for example, but we're still working out how they will access data from Slack and how that connection will go. Okay. So just a little bit on size. So the sizing model, which we're basing on current versions of the pipelines based on reprocessing precursor data, so HSC, dark energy science, survey. And as I said, 25% will be at Slack. The sizing model is basically predicting adding 2,000 cores a year at Slack, giving us about 20,000 in year 10. And then the 3-ring circus will have 4 times that, so since Slack is a quarter. Just if you're interested in the machines, our current plan for these big batch machines are these AMD ROMs with 128 core and 512 gigabyte RAM. And this bar chart is basically showing you the addition of some 8,000 cores across the complex every year. Okay, and then just the breakdowns. So the blue is SSD, largely databases, that kind of stuff. The model that we're thinking about is the DRP. We had planned to use POSIX to do the read-write production of the DRP and then copy it over to Object Store. And it's looking like we can just use Object Store for the whole thing. So those will be adding up the green and red lines. And then tape as well, tape. Okay, so here's a little breakdown of the various kinds of data. And it's ending up to be a good size. So we're talking a few hundred petabytes by the time 10 years come along. And you can see the catalog is a good size, Bromage is down in blue, and so on. Okay, so Mark showed you this already, so I can flash it a little bit. But basically, we have the 3 gigabyte images coming up. And we need them to get to Slack in 7 seconds. So that kind of sets a rate limit all by itself. These come into the data facility. It'll come into a secure enclave that we have there. Then we'll do the alert production and then put it out into our object store. And then we'll be talking to, I think, 7 community brokers, and we're expecting about 15 gigabit traffic integrated to them. And as Mark said, here's the more complicated 3-ring circus. So again, the data is coming up into Slack, goes into our archive facility. We will have been sending data to the French and the UK to set them up for processing. And so again, France is doing 50%, the UK is doing a quarter. This little cartoon on the far right is representative of sort of the processing graph that we're going to be running. And so it's it's pretty complicated. It has a lot of scatter gather steps, and that'll be, I'll talk to that in a moment or two. So the multi-site processing, we'll have in the end 80,000 cores. So we'll be running tens of thousands of jobs concurrently at the 3 sites, and we'll be transferring hundreds of petabytes around. Remembering that 3/4 of the production is not in the US. And then just a reminder that ESNet is handling the traffic between Slack and Europe. Okay, so partly in self-defense, last summer I made this simple model for the network transfer rates. And note that it's the max transfer rates. So if you have something that's maybe short-lived, but has a lot of data moving, it can be the max rate. So in at least the model that I have, the Slack outbound is dominated by feeding those 15 IDACs and the brokers. But it also depends on a number of knobs. So one of them, like Josh mentioned, this model assumes that as we produce the data in the 3 sites, we can be shipping them around as we make them. And so that will depend critically on these processing graphs, whether that's actually continued to be possible, or whether we really do have a gather step where we have to bring everything to one site, do some global processing step, and then ship that all back out again. If we have to do that, then that's going to be, that will really affect the timing of all of this. So as we do our multi-site testing, as we're doing the pipeline testing, we're keeping that in mind. And Mark sort of gave you the scales here, that in principle, this doesn't frighten any of the network providers, especially given the 10-year timeframe. Okay, so in the multi-site processing, we've adopted some technologies. Basically, we've been going with high energy physics, CERN, LHC-based tools, partly because the LHC has been the biggest data producer up until SKI, I suppose, comes along. But they've had to build this basically worldwide system. And so Panda is the workflow management system that we have adopted. This was brought to us by the Atlas experiment, who runs millions of jobs a day at hundreds of sites. And we've been testing this in our interim data facility in the Google Cloud for our first round of reprocessing the dark energy science collaboration simulations. And multi-site testing is just getting underway here. Data movement, we've adopted their tool called Lucio. And I've given you links that can point you to these various tools if you want to read up more about them. So that's basically their tool that orchestrates data movement. And it's a 2-tier thing. So Lucio itself is the source of knowledge for the locations of all the data sets, and it understands all the rules for moving them around. So basically, you just set rules to say, I want this data to be moved over to here. Lucio will take care of it. And so we've been envisaging that as the basis of our data backbone. There's a wrinkle to that in that it's not typically used for low latency activities. And so we're expecting we'll have a custom scheme for the 7-second transfer from the summit. Okay, and then for code distribution, there's a tool called CVMFS, which basically is a way to distribute containers and code. You can also distribute some data, but we're going with software and containers. And that way, we can readily make sure that we're using the same code everywhere. Okay, so here's kind of a picture of these technologies, and I've given you a legend up here. So let's just look at the UK DF because it's right in front of me. So the little green guys are the data movement. So there's the local disk. RSC are the Lucio storage elements. So that's keeping track of the local storage, and DTN are the data transfer nodes. So that's the in and out of how we move the data around. On the compute side, Panda has these things called compute engines, which are basically interfaces to the local batch system. So Panda understands effectively all known batch systems. And so we just send data to the site and it goes, oh, I know the batch system, I will deal with it. And then CVMFS is the way we get the code available to the processes that run. And then we replicate that at the various sites. Okay, and then for the data access centers, we're expecting that we'll set up Rusio storage elements there as our data backbone method for getting data to them. Okay, so if you don't know about Rusio, it's pretty well supported and now is the tool that LHC uses to move their data around. And so I gave you a link to a nice talk that I extracted this slide from. But basically it's like any data can be managed. It manages transfers, deletions, storage. It connects with workflow management systems pretty natively. And you can give all kinds of policies for how you want data to be moved. So we're now getting used to that, and I'll talk a little bit more. Okay, so just a few pictures of the tooling. So there's a web user interface, and here you can just see some of the testing we've done to the site in France and some of and just the kind of information you get. We've done some initial testing to France, and so here you see moving a few thousand files of various sizes just to check the tooling. And so we can see we're getting gigabytes a second to France, but again, we haven't done any tuning yet. So the status and issues might be it. So we're just kicking the tires right now. So we're making sure all the connections work, and we're testing the network throughput. As I mentioned earlier, Rusio isn't really appropriate for these low latency transfers. So we're thinking up a different solution, which we think is just going to be an object store post parallelized. So we have optimism that will work out. A worry is that we have mostly small files. These are tens of megabytes, and we have a lot of them. We're actually expecting on the order of 1 billion files a year, which is more than the LHC experiments. I mean, they have more data, but they're bigger files. And as mentioned, we'll be moving hundreds of petabytes a year, and we'll be collecting them all up at Slack. So we're going to need to understand how we deal with the small files and how we deal with the volume. And as I mentioned earlier, we'll have to work closely with the pipeline developers to make sure that the graphs that they want to execute are executable on that phase. The last step, which is kind of a reality check, is that Rusio and Panda came to Rubin fairly late in the development phase. And a tool called the Butler had already been built for handling metadata and locations. And so essentially we're bolting Rusio on top of that to get the data orchestration and movement capabilities. So there's some functionality that we have to organize so it doesn't get duplicated. But in particular, we're going to have to make sure we bulletproof the connection between the two so that we have to register data sets in both. And we want to make sure nothing gets dropped. And we also want to minimize the traffic between the central Butler and Rusio servers at Slack and then the satellite data centers. Okay, so then the last thing is just a timeline. When do we have to do this stuff? So Bob showed you, I think, sort of a remnant, something of that thing in the upper left. But here's kind of a timeline going up into FY25. So Slack USDF is building itself up now. Mark told you that the data center is being put together and the core infrastructure is being assembled now. So we've got hardware that's being installed, new infrastructure that we're adapting to, and that's happening now. And we're basically targeting this summer to be able to start handling traffic from the commissioning camera and start helping with commissioning. Then for the operations phase, we start going to these data previews and then the data releases. And so this is where we reprocess all of the commissioning data from either the commissioning camera or the actual camera. And these happen basically over the next 2 years. And then come late 24, we'll be doing processing and then distributing the first data release. and that'll be a 6-month data release. So that's kind of the timeline that we're looking at. And I think that's it.
Thank you. It was very comprehensive. Any comments? Yes, Eli, and then Geronimo.
Thank you, Richard. I think that you are right to be concerned about the very large number of small files. I know, well, I am certainly interested in learning about how that works out, especially if you try object store solutions for that. And I think that there will be others in the community as well that are interested in learning more about your experiences there. So I very much look forward to learning what you learn. And yeah, that sounds like a thing to me. Very interested to learn how it goes. Thanks.
And I'm pretty sure you won't be far away from this, for you and Paul and company.
Indeed. And if we can help, of course we will, as you roll around with it. But this is something that others are likely to encounter as well. And with lots of people are investigating object stores. And so if that as a solution helps or hurts for this kind of workload, there's going to be a lot of value in that knowledge in the rest of the science community.
Yep. Okay.
Go ahead, Geronimo. I see your hand.
Oh, thank you. Well, my question is more in a sense, Richard, of for the data transfers from Chile to Slack, are the applications going to be instrumented to provide some sort of reports that as networkers could use in case you start having issues with the 5-second data transfer? Or is it always going to be more like, oh, the network doesn't seem okay, and then we have to figure it from scratch?
Right. I'd say that we're still prototyping the transfer mechanisms. And so we haven't really talked about the diagnostics for that low latency transfer. The slower transfers, so Rusio, we do expect to be handling all the other forms of transfer calibration data and products that go back to Chile. And so that Rusio and the file transfer system both come with their own, I wouldn't say monitoring, but their own diagnostics and tooling there for us to see what's happening. So good point on the low latency transfer. I think we haven't got to thinking about that yet. At least specifically to that transfer.
Yeah, well, but that's good. That's exactly the point, because since you have a large number of nodes sending and a large number of nodes receiving, any sort of feedback that we can get in the most automated approach would be very helpful for troubleshooting.
Yeah.
Thanks. Philip Demar, you want to?
Hey, Richard.
Okay.
Simple question. On the data movement for the data products processing, you showed it logically as separate data movements to IN2P3 and to the UK. Is it going to physically be two separate data movements, or is the data going to go to IN2P3 and then pulled to the UK from there when they do the processing?
Right. So the discussions that I've been on, so the default model is that we send them to France and then France sends it to the UK. The one I think what I've heard when talking to like folks at ESNet is that when the time comes, in fact, we wouldn't have to do that. We could just, there'll be sort of routing dependent packets. And so we'll be able to say, this packet needs to get to the UK and to France, and that the network will make that happen. So I'm anticipating more discussion about that, but the default model is we send it to France.
But we should probably anticipate paths to the UK as well, though.
Right. So my understanding is that the main, there are multiple ESNet paths to Europe, but I think the one we've been talking about is actually going into London. So it's kind of like there already.
Thanks. Luis Nicole.
Don't worry. He knows me. Don't worry. Luis da Costa.
I know your name. Please go ahead.
Nicolas, I don't know how he got there, but anyway. Rich, are you envisioning all the data for the IDEX to come from the US data facility, or you can imagine coming from France, or using Bella in our case, or from Chile?
Yeah. In my model, I imagined a split. And I can't remember what the split was at the moment. But basically, when the time comes, we'll try and figure out how to optimize that. So it doesn't have to come from the US.
Okay.
I think part of it could be just capacity in and out of CCI2P3. So we'll have to see how that goes. The other thing, another knob that I didn't mention in the model is sort of durations. And so how long we take to be able to deliver to the IDEX is another question, because that is kind of a gather step. So we basically have to wait for the catalogs to have been put together to be able to ship them out, I believe. So again,
but if that works, probably since half of the data will be in France, you might as well start getting from there, right?
Well, they will have all the data. Right.
Anyway,
France will have a full copy.
Okay.
Yeah.
Anyway, thank you.
Okay.
Thank you for your question. Any other questions or comments? Well, that was a really great presentation.
Okay.
And Chris Wilkinson with Internet2 is going to have to follow you up. So Chris, you ready?
Sure. Give me just 1 second here. All right, so I'm Chris Wilkinson. I'm the Director of Planning and Architecture for Internet2. I apologize for the raspy voice. I a little bit of a cold, but I'm going to talk today a little bit about, hopefully this will be one of the last updates on our NGI project, which has been going on for about 3 years. And I wanted to sort of provide a holistic view of what we've done on the backbone across the domestic United States, and what some of our long-term goals are going forward with continued development in our software stack and other aspects. So just a quick introductory slide on Internet2. We're a backbone for research infrastructure in the United States. We have a whole group of regional and global partners which provide connectivity both between each other and down through our school districts and government agencies. That forms the ecosystem for Internet2. We also provide collaboration models for that entire group of folks, not just infrastructure, but also tools. We gather community requirements and evolve those services. And then we've started to branch out more and more into providing software and tools that enable the entire community from international down through school districts to interact with cloud, big science, and other large-scale collaborations. So just this fundamental aspects of cloud, there's network, community, and security, all trying to tie it together. So as I mentioned, going to go through our network infrastructure as well as talk through some of our first on-ramps to 400 gig, and then the areas of focus that are from this year and beyond. I think most folks are aware, we started a network upgrade, really not just the network. We really wanted to target the full suite of services from network hardware up through cloud access. So data intensive research, these were our use cases that came out of the community that drove the entire network development. Data intensive research, cloud access, must be software driven, has to be sustainable, and has to be shareable really at all the levels of the infrastructure. So these drove out new features driven by software, lots of automation and virtualization into that infrastructure. And we started in 2016. We're going through the last stages of decommissioning today. So our network footprint has remained largely the same. The big changes to that footprint are massive capacity, full automation into the stack. We have measurement infrastructure, and we've layered in security. So just ticking through some of these in particular, our entire backbone is now 400 gigs linked site to site. The full, we're using NSO and MCP to actually automate the configurations of both the packet and optical infrastructure. Every single red site on this diagram has perf sonar nodes connected at 2x100. So we have a high degree of visibility into what's happening and the ability to test the network from any point of presence on the new platform. We've built an entirely new secure management network across the entire platform that does largely out-of-band management and allows us to collect telemetry throughout the platform. And we've done a huge operating cost reduction across the platform. And I'll touch on each of these a little bit more in the next few slides. From a programmatic and a organizational standpoint, we're doing a large amount of development of our internal engineering teams and our new software teams with the goal overall of layering in additional tool sets and becoming much more outwardly focused as we go forward. We also did a large amount of cloud capacity enhancements throughout the platform. So our major points of presence are in Seattle, San Jose, Los Angeles, Dallas, Chicago, Washington, and New York. Each of these sites grew organically over time. So each site was different prior to the new program. At this point, every single one of these locations is built out in a uniform manner. So each site has 1.6 terabits between the transport infrastructure and the cloud infrastructure to which cloud peers can attach. And this is new. Some of these sites were limited to 200 gigabits per second. Some of them had routers at the edge. Some of them used backhaul technologies. There was a whole variety of different architectures applied across the platform. And now there's a uniform architecture at all these sites. So this allows us to provide all of our services from our settlement-free peering service and our peer exchange down to member-specific services like port delivery into the edge at every single one of these locations. So this is a huge change from our previous operating architecture, and it's already allowed us to scale. I mentioned that we have a 400 gig backbone now. Every single one of these black lines is a 400 gigabit per second link between cities. Some cities have additional links that bring up the total capacity to 1.2 terabits. All of this bandwidth is accessible from the edge, whether you're at a cloud provider or you're at an exchange point. I've highlighted the exchange points here, including a potential future exchange point in Boston that we're working on. Talk about that in a minute. But all of that backbone bandwidth is available for any use or utilization across the Internet 2 platform. This is really important because as is common for y'all, our bandwidth demands have been increasing dramatically over time. The topmost line, the yellow line here, is sort of our total transport at layers 2, and then our various research and education routed service and our I2PX service. Each of these is 2017. These are months, January through December, all from left to right. And each data point is a year. You can see in our current month right here, this was a partial, this snapshot was taken about halfway through the month, so we haven't accumulated the full month yet. But year over year, definitely seeing increased growth across the platform for total traffic carried. And in fact, the new platform came online just as some of our backbone links were about to exceed their capacity management thresholds. for traffic conveyed between cloud exchange points and our members. So definitely, definitely a crucial upgrade at an important time. We've gone from a commercial peering capacity 2 years ago of just under a terabit. Now we're at 5.6 terabits facing our peers. So we've done a lot of capacity upgrades from 10 gig to 100 gig technology facing peers and open exchange points. It's grown substantially. And one of the goals of the platform was to allow this type of scale. Just a few snapshots. This is actually 10 years. So this was when the previous generation of the network first came online. Substantial growth in all the categories. Some of it far exceeding original projections. One interesting data point here is the original backbone in 2010 at 250 gigabits per second total. Now we're up to 127,000, so much larger capacity. One really important point, which is in the upper right-hand corner, is that this is 70% space and 70% less power than the previous generation of equipment. So far more bandwidth for far less space and power was one of the program goals, and so far it looks like we've hit the mark there. And this is really critical for reinvestment, and both of financial reinvestment and reinvesting manpower and time towards application specific or community requirement specific goals. I did want to just talk a little bit about traffic through the pandemic. It's often a question we get. So the year over year is green is 2020, red is 21, and yellow is 22. That's why we've trailed off here. This is same day comparison through the year. One can see that the pandemic in green here created a shift. I mean, typically we see over the course of the year, a very consistent pattern. If we actually looked at this data back over the last 10 years, which we have, you can see that diurnal pattern all the way through the year. The pandemic obviously shifted that traffic significantly, when it first occurred. And then we've continued to see traffic growth. The patterns do seem to be returning. As you can see, the red line is a much more consistent pattern. And that yellow is expected to dip again through the summer and head on out to the fall. One more, just quick slide of a traffic shift that we've seen. This is a large home broadband provider because our campuses use us to get to broadband providers in the cloud. We saw a substantial shift of traffic coming and going from campuses to our home broadband providers domestically. Of course, reaching the end of this massive network upgrade, huge community effort, both good engagement from our PAGs and our advisory committees, as well as our staff in general. So huge, I like to include the slide, it takes a village, as they say sometimes, and we definitely had that. So we are taking our first community members to 400 gig. FLR in Florida, Indiana Gigapop, Mid-Atlantic Crossroads, Ornet, and the Utah Education Network are all among our first members. Some of them are migrating to 400 gig at 1x400 with a native 400 gig interface as their own infrastructure comes up to that line rate. A few are adopting 4x100 as their, as an intermediate step. But this is happening. We're turning up our first connectivity with the state of Ohio. And they'll be migrating all of their services and connectivity, both at the research education level, and as you can see here, taking connections on each side of the state, one in the Northeast and one in the Southwest, to take all their services at, in this case, 4x100. So we're really excited to see this happening. And for some of these entities, they're already connected at 2x100 in these locations, and they're seeing growth beyond that. So this is a big step for a lot of our domestic community. I just wanted to step through a few things about what Internet 2 Network Services is kind of looking at. You know, we are working on a variety of member-facing, and by members, this really is community-facing self-service network products. You know, we had a previous router proxy, and you know, routing security is becoming more and more important. Cloud is obviously key, and then we're integrating all those tools horizontally with our in-common services so that there's common authentication and other functionality to go with that. We've been heavily engaged with routing security across our community, and we're continuing to push that. We're reviewing route policies and other records that are key to ensure there's continuity through the community, and that those routes cannot be hijacked or rejected by commercial parties. Working with our community on community telemetry, that means sharing telemetry both among community members and telemetry from the Internet 2 network and its exchange points out into our broader community, both internationally and domestically. One big shift that's also happening is we are currently undergoing an RFP for our NOC services. And so that is about to wrap up probably in the next 1 to 2 months. We'll go into negotiation with our finalists and migrate that, so that could change the how you interact with Internet 2. One big shift that we're doing is we're onboarding some senior staff and bringing more people into the organization so that we have more folks to work both domestically and internationally on technical and programmatic aspects. So we're excited about that, lots of growth in the next year. And then, as I mentioned, some of that will enable us to, you know, really step up our technical and community engagement. From an international perspective, one of the main things I wanted to just touch on was we are working on a 400 gig transatlantic upgrade with the Amity cable. That's done in partnership with Canary, and both Internet 2, Canary, and ESNet are all looking at capacity on that cable. You know, that will run between Boston and Bordeaux and Slough. Due to come online late in 22 or early in 23, there's construction on the wet plant and a bunch of terrestrial build out for backhaul that has to take place. That includes Internet 2 potentially adding an exchange point in Boston, comparable to Mainland and Wix. So that we're really excited about that. We've started to talk about it. We're still waiting for the final scheduling and cost sharing details, but it looks like it's good to become a reality. We are also working on potential upgrades for our exchange points in Mainland and Wix. Those are older Juniper-based switches that we installed 3 or 4 years ago. And we're about to refresh those so that they're consistent with our domestic backbone infrastructure, which is Cisco 8200 based. They're likely to be NCSs or ASRs as we go through that. When we do that, or even perhaps before, we'll probably be flipping some of our protocols over, again, to be consistent with our NGI topology, using a EVPN instead of EPLS for circuit switching. And then we are in the process of layering in automation to support Fabric. And that's an ongoing discussion with our development teams. One other minor thing that we're supporting is the Open Science Grid. These are effectively DTN nodes that are situated throughout the domestic footprint in the US. And the goal there is to you know, support open science, open data, open infrastructure. Internet 2 is going to be hosting 5 additional nodes. We actually have 5 nodes currently on the network. They're very heavily utilized. This is in step with the National Research Program. It's one of our contributions to the program is supporting these nodes. And we're pretty excited to be expanding our support of that program. Just to touch on the software development work we're doing on our portal. Our development team is currently rebuilding effectively our legacy portal and dramatically expanding it so that there's a new API stack and new web portal. This will eventually filter out into global, into our exchange points and our other hardware that we're operating or the other services we're operating. Down here on the left, you actually can see the majority of our services. This is a mock-up, so some of these are even more evolved from the services we provide today. But you can see global research, DDoS, our commodity last resort service, and on down the stack. So the goal is to provide full access to Internet 2's app stack from L1 up through L3 through this common tool. It's a big undertaking, but it's a long time coming, and it's been a long request from our community to improve our OESS software. Also, this is getting down to the last slide, but we are going to have our first in-person large-scale meeting come December. So we're very excited about that. Fingers crossed that goes as planned. So we'll be in Denver and looking forward to getting together with folks when that comes. So I didn't want to take up too much time, and those are all the slides I have today. Thank you.
Well, thank you. You did very well on time. There's 4 minutes in case anyone has any comments or questions.
Chris, I have a question. One of the services you mentioned was called Ripcord. I love the acronym, by the way. What does that actually do?
So, we've gotten community requests for what's effectively a last resort service in the case of ISP outages on their local platforms. So Internet 2 is a very, I may be a little imprecise here, but we have no intention of getting into the commodity services business. Our I2PX service is intended to be very mission specific for peerings of certain types. But we have gotten requests, particularly from our community members in the hurricane zones, to be able to provide bursts of commodity internet service in emergency situations. So Ripcord's really designed to meet that very specific use case, where your local, in the domestic case, hurricane or lumen connections are down, your state or your state industry, your state, your constituents need internet, and Internet 2 does have access through all these points to provide that. So we actually have 4x100 connections into Lumen. We're looking at adding some additional capacity into Hurricane Electric to provide the domestic community with that access. So it's a little bit of a prototype at this point, but it is actually an operational service, and we are able to provide it in an emergency.
All right, well, thank you. And I like your voice the way it is now. My personal opinion.
I had a question also, if I may. Chris, the cyber infrastructure nodes that you're deploying, what are the services and capabilities running on those? Are they compute? Are they DTNs? Are they cache nodes? What's the deployment footprint look like there in the use model?
So it's interesting. The NRP model started out as cache only. And what we've seen is that as they've had, and this is not my area of expertise, I'm largely a transport engineer, so I may go a little carefully into this, but what I've seen, Eli, is that they have actually diversified into also having compute. Some of the new nodes have additional cache space, and they have GPU capabilities. So as NRP's use cases have shifted, and as their overall community has grown, those nodes have evolved as well. So as far as I understand, some of the newer nodes are actually participating in all 3 ways.
Okay, that's great. Thank you very much.
Yeah, yeah, and I think that's ever evolving, but that's my understanding.
Well, sure. I mean, once you've got stuff deployed, right, then, I mean, especially if it's got an orchestration platform bound to it, bringing up a new service is a relatively small increment, right? So that's great.
Yeah, and I wish I had a better map. They've actually deployed a large number of these nodes at campuses as well.
Yeah.
They like ours because they're on the backbone effectively. So they're connected directly to the network hardware, which is their real, they have very low latency and they're not dependent on local transport conditions or campus network conditions. So they've been maybe not surprisingly, they've been very popular. And so that's why I think there's been a push to further expand them. So I expect to see more and more of them across the footprint as time goes on.
Yeah, well, performance attracts workload, right? So that's
absolutely. It's that paradigm does hold here for sure.
Well, let us move forward to Paul Weffel, who's going to present on ESNet, and then we have a little block of time for more open discussion. Paul, I see you. There we go.
Okay, there we go. Can you hear me okay?
Yes.
And the slides are showing up. Okay, good.
Everything looks good.
All right. So, well, thank you. My name is Paul Weffel. I'm a network engineer at ESNet, and I've been involved with the Vera C. Rubin project in one form or another for at least 7 years now. I've actually lost count, but I'm glad to be here. Presentations have all been great until now. So kidding aside, let's get into it. Okay, so even with the pandemic, we've been busy at ESNet since the last SA3CC conference, and there are a lot of updates I'm going to try and touch on as many as I can. Apologies in advance, I'm not providing enough details, but everything I'll talk about has a more focused presentation available, or I can put you in touch with project leads if interested. So I'm going to begin with a quick overview of ESNet for those that may not be familiar with us. ESNet exists as a Department of Energy facility, providing high-performance networking to enable science facilities in their research to discover and transform our understanding of nature. And I like to add the universe to that as well. This is a somewhat dated depiction of the network topology from our ESNet 5 days, but it still does a relatively good job giving a sense of the scale of the network that we manage today. A year ago, I presented this traffic growth chart showing the effects of the pandemic and our previous projection of roughly 10x growth every 4 years. It also shows the, as I mentioned, the little dip in the pandemic there. But we now have another year of data, and it still shows an exponential increase in traffic over the last 28 so years, but we have seen the slope slow down a little, and our 10x growth rate has gone from 4 to about 4 3/4 years. So we expect more science facilities like Rubin and the high luminosity LHC to come online in the near future, and so we continue to prepare for the growth slope to increase again, which is why we embarked on ESNet 6 many years ago. I guess it's been 3 or 4 years now. So, the ESNet 6 project. So what have we been doing the last year since the last update? ESNet 6 has been the follow-on generation for the network and is designed to handle that projected growth. But implementing a new network while minimizing disruptions to operations has been a lot like rebuilding a car while you drive it. And that's definitely posed some challenges to the implementation team. But I think we've been managing it pretty well. And this picture always just amazes me. Oops, why is the slide not going? Okay, there we go. So in the last year, we have deployed Sienna WaveLogic 5E transponders in the backbone to augment the already deployed Infinera G30 transponders. We've brought up 74 plus 400 gig circuits on those wave servers. We've done a proof of concept upgrade on 3 of the Infinera Groove 100 gig circuits. Those are capable of supporting 400 gig, and we've migrated 3 of those circuits to 400 in preparation for the project to migrate the rest of them to 400. So this now gives us a mixed vendor transponder system, which will reduce the risk in a number of areas associated with bulk automated changes, firmware bugs, equipment failures, and it provides us more options for future upgrades. We also finished deploying and bringing into service 42 new core routers, and we've decommissioned most of the old routers and rolled traffic off most of the 100 gig circuits. So during the implementation process, the backbone has evolved in steps, and today we are over here now at the 4th step, where we're migrating the remaining 100 gig circuits to 400 gig with the goal of getting over here to the final stage of 400 gig everywhere. This is a visual depiction of the currently deployed capacity, well, current as of March. Our goal is to move here to December 2022 target, where we have basically purple, green, and blue everywhere, except for, of course, the transatlantic links and our 200 gig European ring, which I'll touch on that a little bit later. So the SA3CC project has brought about a number of new services. The most recently deployed is the backbone black hole routing service. This moves a largely manual process to a more automated framework for blocking malicious traffic like distributed denial of service attacks or botnet command and control. And this forms the foundation for upcoming future advanced security services. Interesting thing, the day before we were going to deploy this into service, we did get a report that there was a DDoS, a possible DDoS attack that they wanted squashed. And so we were able to use the new system to do that. The graph below here shows the traffic that the system was suppressing. Okay, so automation. Automation is a big component of ESNet6 and the foundation for all of our future services. We've made great progress building up the automation stack, and we only have a few more services left to automate, which are in development now, which would be supporting L2 VPN, L3 VPN, and integrating more with the high-touch service. The automation workflow goes something like this, with the main components being the source of truth, which we call ESDB, the orchestrator, which manages the workflows and talks to NSO, which pushes out configs to the network and maintains state for the whole network. The network engineer interacts with the ESDB and orchestrator to define the intent, and then it gets pushed out to the network. So far, we've automated the connections to 42 of the routers, which involved over 1,800 subscriptions in the orchestrator. So for reference, one subscription is a workflow the orchestrator executed to deploy something. So for example, the complete turnup of a new peering today requires roughly 6 subscriptions to be completed in the orchestrator. We still have work to do to automate additional services and then build in features to allow us to automate the more bespoke configurations that all networks seem to always have somewhere in the closet somewhere. Our friends at SurfNet wrote the orchestrator software that we've adopted. And this is a screenshot what the orchestrator looks like as implemented at ESNet. The top section shows some network elements enrolled in the orchestrator, which is the first step to allow the orchestrator to operate on them. The lower section here is just showing workflows in various non-active states like provisioning or terminated. All right, monitoring. Told you there's a lot of different things. Monitoring. So we have spent a lot of effort developing what we call Stardust. It's our new monitoring platform built off the work that was done with the NSF-funded NetSage project. Stardust is a cloud-hosted system, but we've engineered it to allow it to be pulled in-house if needed. It's built on the Elk stack with a Grafana front end, so it uses Elasticsearch, Logstack, and Kafka. The system ingests many different types of data from the network, like flow data, SNMP, BGP routes, streams from the high-touch system, sonar data, and then it also enriches it with metadata that's pulled from external sources like our ESDB, PeeringDB, the Science Registry, or just about any external data source that we can pull from can be used in Stardust as metadata to enhance reporting capabilities. So when Stardust was conceived, we had some design targets of how many events per second we were going to have to handle. Our current ingest rates are exceeding that, but we've added a lot of additional data sources that we didn't originally anticipate. But being in the cloud, it's easy to scale. All we have to do is write a bigger check to Google. We're trying to keep data currently for roughly 30 days for the raw data with aggregates and rollups for much longer durations. So from this data, we have a set of pre-made standard dashboards that we have available for the engineers to provide frequently used insights into the network. We have flow-specific breakdowns. So by ingesting BGP data, we can do things like ask to see how much traffic we exchanged with Riona or Amlight, for example, and which peerings and router links did we use for that traffic. If we have a full backbone link, we can get a breakdown of the traffic source and dest traversing that link, as well as the ASs and the science projects that are using that link. So far, Stardust is proving to be a fairly powerful system, and I think we're just beginning to tap the capabilities. We can make custom public-facing dashboards for events or projects. This is an example of a dashboard created for the 2021 LHC Data Challenge. There's a link that's down here in the slides that when I post these, you will be able to use to visit the public dashboards and explore them yourself. We're currently working to ingest and instrument the optical system into Stardust to further augment the other data in the system and to provide a unified view of our multi-vendor optical network so that we can move away from hosting multiple vendor-specific applications. This slide shows the data pipelines for how we are enriching the Stardust data with telemetry from our high-touch system. Differently derived information about the network flows take parallel paths from the router into Stardust and then are processed using various algorithms and then displayed in reports on dashboards. So, whoops. Okay, so I mentioned the high-touch system. I've talked about this in the past. I'll touch on it briefly here. Again, if anybody would like more details, we have much more detailed presentations about the high-touch system that are available. But in a nutshell, the main routers mirror traffic into the FPGAs. The FPGAs run the traffic through some code, distilling it into whatever you need, and then software on the host CPU will process it and send it out as a streaming flow. In the future, we hope to be able to pipe traffic through the FPGA and back into the core to do various things with the packets themselves, but that's still in development. This is the core of the high-touch system. It's the custom FPGA. And this is one of my favorite slides, which shows where the code for the various functions actually live in the FPGA logic blocks. All the black space is space that's there for additional code for future functionality. Okay. So transatlantic upgrades. Well, Chris mentioned this already. Okay, back in the late 1800s, just to remind us where we came from, this is what we had for transatlantic connectivity, right? Telegraph lines, Morse code. Today, right now, ESNet has 4x100 circuits on diverse lines going over to Europe for our European ring. And as Chris mentioned, we do have spectrum on the OMNI cable, and the spectrum is enough to provision 400 gig circuits today. And we're hoping with the improvement in transponder technologies, we'll be able to upgrade those to 800 gig. We are also currently pursuing several other additional spectrum opportunities with other TA cable providers so that we'll have more capacity and increased resiliency. Okay, and that's all, folks. Thanks for hanging in there. Any questions?
Sure. I'm curious about your black hole service. Are you subscribing to a third party to provide data that you're just updating? Or, I mean, I guess could you say a little bit more how that process works?
Sure. So it's actually not using any third-party data sources. Currently, it's a portal that you visit, or it has an API that programmatically could list prefixes to block. The intent is that our site will be able to have an authorized representative log in and perform a block as they need to on their own.
All right, and that's per site, or is it wide sweeping across the whole network?
So it will block at the border into ESNet to prevent.
Okay. Yeah. Wow, that's pretty cool.
Well, thank you so much for that update. And I guess we can move into our discussion session. I'd like to give Joshua a chance to ask Chris his question from the Internet 2 presentation. It's in the chat box, Chris. Yeah, you're still there.
Yeah, having a look. I think the plan is that will migrate from, and I'd have to go look at the roadmap. I believe we're migrating that from a global NOC based service to an I2 service. The question was, is the router proxy going to continue using global NOC services, or is it going to be an independent deployment? I'm actually hesitant to answer that because my recollection is that it will migrate to be an independent deployment, but I'm not 100% sure about that statement. So,
okay. But currently it is using global NOC services.
Correct. Yep. Yep.
Okay. Well, this is general discussion. Maybe Julio or Bob, you could say a few words to kick it off, or send us home, as you wish. And I don't know where they are.
I'm here. I thought we heard a lot of great talks today about all the different aspects of the networks that are connecting us together. Many of them related to many of our projects, some of them independently. So, I don't have any specific concerns or questions right now, but just to say that I thought it was a really good overview and discussion of where the overall landscape of the SAC is right now.
My thought on that would be,
excuse me, someone here has their mic open.
And we'll look specifically at where we're at score-wise, but then.
Okay, thank you.
I got it, Heidi.
Yeah, Julio said his Zoom crashed, so I guess he'll be back with us in a minute. I really want to thank everyone for spending the day here from all the different time zones. It was very nice and great presentations. Wow. I think we can adjourn early. If there's nothing else. The net meeting is the next 2 days. Some of you are probably participating, and we'll be reaching out in general to help us with the report from the SAC.
Thank you, Heidi.
Thanks. All right.
Thank you all. Bye-bye.
Take care. Stay healthy. Bye-bye.
Bye-bye. Thank you very much.